Hello. Most of the participants are still joining. We will wait and will continue within few seconds. So it seems most of the students already have joined. So we will continue with today's lecture. For the day Friday 19/3/21. This is the second serial lecture. So we'll continue with physics. Yesterday on 18th March, we studied what is PN junction. So when two separate intrinsic semiconductors, one is N type and other is P type, are fused together or joined together in the contact region, we get formation of junction and the entire thing is called PN junction. At normal condition, it has unbiased state. No current flows through it, that is called zero current stage or unbiased stage. We studied its few characteristics and we concluded that after biasing, this PN junction shows different peculiar properties, and after biasing you can control the current through it. So yesterday we studied the PN junction in unbiased state, in forward biased state, and third mode is reversed biased state. So this is its principle. This is the theory part. When such PN junction is formed, automatically by default we observe depletion layer near the junction in which the charges free are not present. That develops potential difference near the junction. So to P side negative potential, to N side due to accumulation of positive donor ions we get higher potential. So electric field gets developed and that is called barrier potential. When such PN junction is used for other practical purposes, it carries metallic connectors, and such PN junction with metallic connectors is called junction diode. So this junction diode is used for all practical purposes in electronics. It is the basic or fundamental of electronics branch in physics. So today we will proceed and revise the characteristics and peculiar properties of PN junction diode. Many times it is simply referred as junction diode. So the junction diode is nothing but PN junction having metallic connectors, so that PN junction can be used in electronic external circuits. So this is all about junction diode. So we studied yesterday its theory part. The junction diode at normal condition is in unbiased state, but it can be biased and it can be used for further purposes to carry current through it or as a switch using its biasing. So biasing controls, very important, biasing controls the use of junction diode in external circuits. Can be biased in two ways. One is forward bias and the other is reverse bias. So in forward bias mode, P type, N type, these are metallic connectors. P is connected to positive of external electric source and N side is connected to negative of external source. What happens here? Itself it has electric field. which points from N side to P side. But when external field is applied, it is from P side to N side. So both have opposite directions. So till the value of external does not overcome the barrier potential, even if the circuit is closed, it is made on up to certain value, you don't get any current. Go on increasing the value of forward biasing. When it overcomes the value of barrier potential, initially a small current flows through it. If you still further increase the value of electric field applied, then what happens here? The barrier potential decreases. The width of this depletion layer reduces in forward bias because this overcomes the default barrier potential, and since reduction in depletion layer, reduction in opposition offered by PN junction diode from itself, current starts flowing. The conventional current will be from positive terminal to negative terminal, and after certain value of this applied potential, if I plot graph I against V, this is called IV characteristics. We are increasing V continuously, step by step. When V is 0, I is 0. For smaller values of V till it reaches barrier potential for given diode, current very small, almost zero current. And after certain value of V, the current starts increasing. So this is called IV characteristics of diode when is arranged in forward biased mode. So here large current can flow through junction diode when it is made forward biased, and hence it behaves as closed switch. It conducts in large amount. 1 minute. It conducts in large amount. And hence it can behave as closed switch. When the other way, if it is used in external circuits applying reverse biased. Reverse bias means what? The polarity of applied voltage is reversed. Negative is connected to P type and positive is connected to N type. So when this is the condition, what happens? The free charge carriers, holes, and here are number of electrons. This is depletion layer. It has its own barrier potential. These electrons get attracted towards positive. These holes get attracted towards negative, and these free charges from each region move away from the junction. Hence what happens? The width of this depletion layer increases automatically, because here the source is assisting barrier potential. Both are in series, and hence the width increases, barrier potential value increases, and it resists the flow of charges through it. But even these charges are drained out from the junction due to thermal agitation. A very small amount of current flows through this junction. This current is called reverse bias current. It is of the order 10 raised to minus 6 milliampere. इतना कम current nano ampere, 10 raised to minus 6 into 10 raised to minus 3, you will give you minus 9. That is very small current, negligible current, almost zero current flows through this for increasing value of reverse bias due to increase in width and increase in barrier potential. But what happens if you still increase value of width? Reverse bias means you are increasing negative voltage, so it will come to the left side towards negative x डायरेक्शन को वो आ जाएगा. Initially no current, almost zero current, but the stage reaches where at one particular value while increasing it the diode damages and large current flows through it. Even no increase in voltage further in reverse bias, the damage of diode occurs and hence it will behave as open circuit. It totally damages. All covalent bonds break due to increase in potential across the ends of diode, and this is called avalanche breakdown. After certain value of voltage, the diode damages, it passes maximum current, uncontrolled current through it after certain voltage, and it now will behave as open switch. It does not control the current. It cannot be recovered. Once damaged, you have to throw it out. So that time it will behave as open switch. So when forward bias, it behaves closed switch. When it is made reverse bias after certain voltage or from the point zero, no current, almost zero current. This is called leakage current. And this leakage current is due to thermal agitation. Due to thermal agitation at room temperature, few covalent bonds break and the charge carriers are able to cross the junction. Even negative is applied towards it, and hence you get leakage current of negligible value, that is almost a zero current. This is the property of junction diode, and hence it behaves as one-way switch. It carries the current only in one mode, and it is thus useful as electronic switch. Many times this junction diode is used for electronic switch purposes. So when it is forward bias, it conducts, and hence using this forward bias, since we have drawn IV characteristics, you can define its resistance because V upon I is resistance. So it offers resistance for the flow of charges even it is connected in forward biased mode. So what happens in forward bias? Up to certain value, almost no current, negligible current, and after certain voltage, when overcomes barrier potential, you get current in it. So it offers resistance. So we using this IV characteristics in forward bias, we are able to define its resistance. The resistance of PN junction in forward bias has two values. One is called DC resistance. It is called static resistance. And the other we can define AC resistance, which is called dynamic resistance. These resistances only can be defined when is used in forward biased mode. So DC or static resistance is nothing but voltage upon I. It is regular resistance. According to Ohm's law, we can find its value. But dynamic resistance is AC. It relates the resistance over the range of voltage and corresponding range of current. If you draw tangent, एक किसी पर्टिकुलर वोल्टेज के लिए you have to draw tangent and you have to derive the slope of that tangent. So at this slope of tangent drawn at one particular voltage, it's called its dynamic resistance. So you can define, and these resistances are very useful for further calculations. DC resistance as well as AC, which is generally called dynamic, and DC is generally called static. Static is found using simple Ohm's law, while dynamic is drawn at one particular value of voltage. At this voltage, its dynamic resistance is delta V upon delta R. So that value changes when you change the value of V and the position of tangent drawn. So this is all about the junction diode used in electronic circuits. So which completes the theoretical part of chapter 14, that is semiconductors. This PN junction diode is one famous advantageous semiconducting devices. We have few more semiconducting devices which are has practical importance. The most another useful is thermistor. So we have switched over to page number 255, article 14.10, which is the last point from the chapter under discussion. 14.10, thermistors. So one of the famous devices semiconducting type is PN junction diode. We come across different semiconducting devices we normally use in daily life. For example, LED, solar diodes, which are used in solar panels, then transistors, photoresistors, photodiodes are different semiconducting devices commonly used, and they are designed using fundamental basic PN junction diode. The another semiconducting most important device is thermistors. So thermistors are semiconducting device which is sensitive for temperature. A small change in temperature changes or alters the properties of thermistors. Its resistance we control with the help of temperature. These thermistors are made up of powders of oxides of semiconductors mixed together in suitable proportion. So सेमीकंडक्टर्स मटेरियल्स के ऑक्साइड्स की पाउडर की जाती है और डिफरेंट पाउडर्स इन प्रपोर्शन मिक्स किए जाते हैं, एंड फ्रॉम दैट वी found or we derive thermistors. So thermistors is very important semiconducting device which is thermally sensitive, which is temperature sensitive. The thermistors are of two types, NTC type and the other is PTC type. PTC, positive temperature coefficient of resistance, and NTC is negative temperature coefficient of resistance. So few thermistors are designed for which temperature coefficient of resistance has positive value, and the other or few more for which temperature coefficient of resistance has negative value. अतः positive value में क्या होता है? If you increase in both types, both are thermally sensitive. If the temperature is changed, their value of resistance in both types immediately get affected. Small change in temperature produces much large change in their resistance values. But here in PTC, if temperature is increased, its resistance increases, and for NTC, if temperature is increased, resistance decreases. This is only the difference. So wherever you want to measure the temperature, where you want to sense the very small change in temperature, NTC type thermistors are beneficial. So wherever you want to record the temperature, NTC type thermistors are used. PTC type thermistors are generally used in series. For example, फ्यूज फ्यूज है ना, अपने घर के फ्यूज होते हैं, वो जो लाइन मेंस लाइन आती है घर में तो हम लोग शुरू में फ्यूज बनाते हैं और द अदर्स देन थ्रू द एंटायर हाउस you get that circuits connected. So fuse, what fuse does, it protects the next circuit. If this fluctuates AC voltage, actually it is of order 230, but when it fluctuates, what happens, the appliances inside will damage because they are designed only to run on 230 volts AC. So if fluctuation becomes very high, then this fuse melts. So like fuse, these thermistors which have positive temperature of coefficient are used in series combination. ये ध्यान रखना है और एनटीसी में जो है वो दे आर जनरली यूज एज टेम्परेचर सेंसर्स. सपोज आई वांट टू फाइंड द टेम्परेचर ऑफ Earth atmosphere at higher altitude. What is done? The balloon is taken. The thermistor of NTC type is fitted in the balloon. Balloon goes up and with remote control, the resistance of the thermistor is recorded. Finding out resistance value at particular atmospheric layer, you can find the temperature of that remote layer which is far away from us. So for temperature recording, to find minute changes in temperature, NTC type are preferred as temperature sensors. So use of thermistors is equally important. So this is the last article to be considered from the chapter. So with this, we have concluded chapter 14 semiconductors. I will just go on reading the question I have made and we will consider revision. In the chapter, what we studied? First, we studied energy band structure of isolated atom. Then we switch over to study energy band structure of solid crystal. But solids are of different types, few conductors, few semiconductors and few insulators. So with the three different, we studied their energy band structure. So I have drawn the questions. I will read it. First question I have drawn. What are valence band, conduction band and forbidden gap energy for solid crystal in general? Second question, what is semiconductor? Third question, draw energy band structure and explain it for semiconductors. Fourth, we can say explain crystal structure of pure semiconductors. Next question, explain the ways to increase conductivity of pure semiconductor, that is intrinsic semiconductors. 6, what is doping? The question number 7, define donor and acceptor impurities. Give 2 examples of each. Next can be asked, distinguish between intrinsic and extrinsic semiconductors, or also distinguish between p-type extrinsic and n-type extrinsic. Explain features of n-type or explain features of p-type extrinsic semiconductor. What is doping? What characteristics the dopants possess when are used for doping? Then we switch over for junction. So for that, we can ask the question, what is junction? What is its depletion region? What is barrier potential? How is depletion region formed in PN junction? Explain the working of unbiased PN junction. When junction is created without biasing at normal condition, what is its behavior? Explain the working. With neat diagram, explain IV characteristics of junction diode in different modes. And one more left, if the unbiased junction or if you consider ideal diode, diode offers zero resistance, then what is its IV characteristics? जो आइडियल डायोड होता है उसका आईवी कैरेक्टरिस्टिक्स क्या है, ये भी क्वेश्चन पूछा जा सकता है. ऑन पेज नंबर 254 they have drawn the figure. Look, get up page 254. Look at the figure 18.21. On page 254, figure number 14.27. That point relates IV characteristics for ideal diode. So for ideal diode in forward bias, since offers zero resistance, irrespective of value of voltage, the current will increase. And in reverse bias also the same case. If voltage is increased, it will not follow pass any current. Value of I everywhere will be zero. So this is for ideal diode. Ideal diode offers zero resistance in forward bias and infinite resistance in reverse bias. So being infinite resistance, if you increase value of voltage, it does not permit current to flow through it. So this will be along negative direction of x-axis, and IV characteristics of ideal diode in forward bias, since offer zero resistance, current will have maximum value. Without application of voltage, current once starts flowing through it will continue till infinite time. So such small bit questions can be asked, can be said. So I have just given you the sample questions. I will post question bank for this chapter till tomorrow. Everyone has to solve the question bank in classwork notebook, also in assignment notebook. Twice you write, because this chapter no portion is omitted. Only the omitted part is 14.8, that is semiconducting devices. So that much part is only omitted. So you prepare this chapter very well from exam point of view. I will post question bank also with model answers on this chapter. Tomorrow we will continue with further important chapter, that is electromagnetic waves. Again this chapter number 13 from modern physics. So we'll complete modern physics and then we'll switch over to the last chapter, magnetism. So tomorrow be ready to study chapter number 13, EM waves and communication system. Thanking you all to join the meeting. I am concluding. I am winding up. I am closing the meeting for all. Thanking you all again.